I'll try to be brief. However, Michaela has achieved a lot. In a short sentence, I could say that Michaela is a formidable expert in connecting several and distinct fields like science, art, design, technology, investigation, and industry. You don't believe me? Well, let's start then. Right now, she's chair of the Industry Commons Foundation, which is building a legacy for cross-domain interoperability. Sorry.
Yeah, the worst word in the world.
Yeah. Additionally, she was European Human Innovator of the Year in 2017 and was named Innovation Luminary by the European Commission and Intel Labs Europe. I could go here long this day enumerating all the stuff, but to keep this short, I'd like to mention that she has 25 years of experience in developing products, features for a series of international clients, including Apple, Nike, and Nokia, and is co-author of a patent in music AI. So much more to say. And before giving you the word, I'd like to quote an inspiring message of you saying, after all, technology is and always should be a means for human empowerment. And so I give you the word. Thank you.
Thank you, Joao, and such a generous introduction. I'm not sure I can continue on this now because in fear that I might disappoint. And thank you so much for inviting me to this conference. I will also show you the diversity that exists in our community. I'm a founder of a community that now counts over 7,500 members that are both from engineering and computer science and from design and the arts and even from policy and from industry. So it's something that I actually want to show you the diversity that happens because the kind of people that we are able to include in all of our experimentation and all of our laboratories actually end up influencing policy at a high level at the European Commission. And I'm a very, very privileged position to be able to feed policy directly from what we call grassroots experimentation, which is kind of unusual. You don't get that every day. So I really want to show you some of this. So let me start the dreaded share on Webex. So I'm hoping you can see my screen just now.
We can see it, yeah.
That's great.
If you could put the presentation in full screen mode.
I can try and put it into full screen. Let's hope it doesn't freeze because Webex has been famously kind of doing that.
Or at least a little bit larger, maybe.
Yeah. Okay. Let me see if we can do that. Does that work? And can we work with this? Okay. Fingers crossed that it doesn't freeze on us. So the title of my talk is A Space of Common Understanding. This is because I'm a sort of a bridger and some people say also an orchestrator. So a bridger across different disciplines, different domains, but different areas of activity as well. It's not just academic disciplines we're talking about here. And also an orchestrator in the sense that I put people together, I love putting great minds together. I feel that we can achieve a huge amount by doing that. So, and as I say, I feed all of the findings directly to policy. So, talking of policy, you will be familiar with our wonderful Commissioner Gabriel. This is her saying that culture and creative industries are my top priority at the beginning of this year, and this hasn't changed. This year has seen some major progress on this front. On the other hand, we have another commissioner who says the battle for industrial data starts now, and this is Thierry Breton. And you might wonder what do those two statements have in common, because they don't apparently have anything in common at face value, but actually I can show you how much they have in common. Another political figure that may be familiar to you in Portugal, of course, our former Commissioner for Innovation, Carlos Moedas. And this is actually a moment when we were asked by him and his crew to literally invade the European Commission and the Parliament with some experimentation in front of VIPs. And the person holding this neurofeedback sensor is Francisco Teixeira, who is Portuguese from Porto. And here there was an experiment, a live experiment, where we were translating data from commissioners, literally reading neurofeedback, translating it into visualization and sonification, so sonifying and visualizing his brain activity during question time in front of VIPs. So this is a very unusual experiment to do. The first time, we hadn't tried before. This was live. And he is very brave to do that, but of course he's a very intelligent person, and I said at the time, if we had tried it on some other politicians, maybe it would have failed. So another politician who maybe has come back on sort of in everybody's minds right now, back in the last month of his presidency, we were very honored. We had no idea this was going to happen. He was guest editing Wired US, and he chose us, the MTF community, and our champion, Victoria Modesta, whom we see on the right, as one of the future technology frontiers. And at this point, it was a huge challenge for us to show what we can do. You know, if someone puts you on a pedestal like that, you really have to prove it. So let me show you a little bit in this video what it looks like to be part of our lab. Can you hear the audio?
Yeah. We can a little bit laggy, but I believe that's the problem around the environment itself.
Okay. Yeah.
Many brains walking around. I'm totally amazed by this place, honestly. It's my first music.
The most important thing are the conversations that happen, the cross-pollination of different skill sets.
I can speak easily, communicate easily in this kind of environment. So the interesting thing about NTF is that every year there's a theme. And we try to use that theme to help our development that year. Chose this AI lab because AI is something that is inevitable.
The first step is that AI is actually a companion, right, for humans and how many human existence.
There's a whole bunch of different projects happening, but what I see is a number of different specialists interacting, trying to speak to each other.
Creating own stuff and creating new stuff. I was like, it would be really cool to see what they do.
What I think can be interesting is to challenge what human can already do. If it can expand our boundaries of perception, if it can challenge us to be even more creative. So yeah, I'm really looking forward to see what comes out.
So this is Victoria Modesta, and I mentioned her before. And when we started to do longer labs, so several immersive days of experimentation, I felt we needed a role model, and I picked a woman. I wanted to be a woman, and a woman who's a champion in technology and in accessibility, and also bridges technology, very much technology and the arts. Victoria is now a fellow of MIT, and she's very, very brave also as a performer. She breaks new grounds, as you can see here. And one of the first things we did was we said, okay, how can we look at new ways in which she can express herself through technology? And one of the nice things that happened was that her attitude is that her prosthetic leg, for instance, is a tool or is a basically a tool for expression. So how can we make that happen? It doesn't have to look like a sort of human leg. It can actually be a device. And in this case, it was turned by Anouk Wipprecht, a wonderful designer, a Dutch designer in fashion tech, to make smoke for the stage in reaction to sensors. So she was able to create this image that was like the old Marilyn Monroe with the dress being lifted by the wind, but in this case it was smoke that was creating the dress with some carbon fiber dress and sensors. But what was really important for us was that we wanted to see what other ways that we can actually drive systems. And the MuArts team, who's actually from Porto, fitted her with neurofeedback sensors, which were allowing her to train herself to control the lights of her dress. This comes from clinical trials. It's actually a system that allows you to visualize the data that your brain is outputting, and then in reaction to the data, to the visualization, you're able to train your brain to do something different. And in this case, she was, by the end of the week, it took her a few days to train, but she was able to control the lights on her dress and use this as another mode of expression. So we are completely bypassing language and jargon when we're doing these things, and we are actually using other types of human qualities. And we took this further at Slush. Again, MuArts team were there, a huge amount of scientists and computer scientists, data specialists, accessibility designers, artists, all kinds of people. And we had, in this time, we put blind singer Rika Hänninen at the center of the lab. This was part of Slush in Helsinki, which is, you probably have heard of Slush, one of the biggest conventions of startups and investors. And for the opening of Slush, they asked us to do something really special. And we worked for a week, inventing completely new ways that we can communicate to each other. And of course, we wanted to take this idea of using neurofeedback to drive systems further. So this time, it was actually tuned to be able to go up and down the musical scale. And the first thing that we did with the blind singer was ask her, okay, what do you really need? What are you missing when you perform? And she's a very professional person. She's from the Sibelius Institute, vocal coach, a huge range. But whenever she performs, she can't see people's reactions. So she said, I want to be able to sort of see what people feel or feel what people feel. So the first thing was super simple. We just fitted the audience with pulse sensors. And all of a sudden, she was able to communicate with them. So sometimes the solution is very, very simple. Pulse sensors are just a very cheap little device. But the neurofeedback progressed a great deal with this idea that the MuArts team had to turn it into a musical instrument. And people in the lab started to train to play music directly from their brain. And it was taking them about 2 hours to start to go up and down the musical scale. It's not an easy process, but having said that, compared to a musical instrument where you have to train your muscle memory, it's actually very fast. But then the amazing thing happened. Rika, the blind singer, put the neurofeedback sensor on, and she was able to play immediately without training. And therefore, we realized that with these new systems that we were creating, all of a sudden, we were getting people who were previously in the mechanical era called disabled because they couldn't move a lever or they couldn't see the controls. They were now, in this particular environment with brain-computer interfaces, far more talented than the rest of us. So we thought that was a real breakthrough moment for us, because as a community and a global community that spans literally from New Zealand to Alaska, innovators and inventors and postgraduates and graduates and all kinds of, and lots of professors and high-level people, we are able to really contribute to the new systems that we're building for people, to enable people to express themselves better and to communicate with each other. So this was, for instance, a visualization that was showing the public. It was showing it in real time what Rika's brain was doing, and it was reacting to her. It was very clear, if you were in the audience, that this was a live thing. So this is the sort of there was, I think it was 30 people on stage in Slush, and these were the types of people, you know, people with implants, people who were cyborgs, people who were from the audience, people who were designers, people who were directors of gaming companies, etc. And this is the sort of diversity that we have in our community, and they're just amazing, amazing minds. And we assembled a number of them several weeks ago during COVID, and despite of restrictions, or rather, with very careful respect of restrictions, we had 45 people in Aveiro from 22 countries doing this. And if you look at this, this is the number of women in a lab that, you know, we very, very quickly found out that we were attracting a huge amount of women technologists and innovators. So, for instance, this is a screenshots from the a documentary that MIT made about us. And this is our experience, because we've been running since 2012, and in the original coding hackathons that were they sounded a bit engineering-y, we would struggle to get 17% women, and then we introduced a creative lab, and it rose to 33. So in terms of inclusion, the creative element is incredibly important. And what we thought was that was not enough for us. So we thought in Sweden that we would put women as role models for all areas of technology. And therefore you would have here, for instance, you might recognize some faces here. There's Imogen Heap on the left. She was our in charge of blockchain. In fact, she ran our blockchain lab for the whole week. Robin, the singer, she was in charge of Girls in Technology. She's an initiator of this really, really wonderful thing called Tekla. Anouk Whippert I mentioned already. I don't know if you see on the right, it's Danica Kragic, one of the biggest AI professors recognized globally. She's an expert in AI and robotics. People like Nancy Bain, who's a senior in Microsoft Research in New England. Kelly Snook, who was with NASA for 19 years. LJ Rich, who's a BBC Click presenter, and Ginger Lee, who's an award-winning data visualizer from Florida. So this is the sort of people that we ended up putting, even though this was not a female event at all. And we had 800 people from all genders, and what we were very proud to achieve as a result of this effort to make women role models prominent, we ended up with 53% women in an 800 participant prototyping, technology prototyping event. Kids. So this also applies to ages. So all age groups, we have, I think, 3 to 83. And this is our latest DJ from Stockholm. And all kinds of areas of ability. So, for instance, at Setúbal here, you have one of the projects that came out of Music Tech Fest that was by a company called Human Instruments, who have been members of MTF for a very, very long time. Here's them with one of the latest projects in collaboration with Drake Music in London. So Tim Yates is from Drake Music, and Tim Palm, who's from Stockholm and who is a computer science student as well as being a DJ, who's built himself a DJ rig that's completely different and adapted for him. And then the guys jumped on board and enabled him to do things he could never have done, for instance, such as play guitar, which was one of his dreams. To cut long story short, and you can look into this project, they ended up winning. He ended up being played on the BBC 2 days after he first demoed his new composition. He's been featured on BBC Six Music since. He's actually founded a company, and they won the National Sound Awards. This is just one example of what happens when you enable people to be able to communicate in ways that they haven't previously, or express themselves in which they haven't previously. So our background is in when we first started, my ambition was, let's bridge art and science and academia and industry, because I had a huge amount of experience of doing this. And this is us in London with the London Symphony Orchestra. And the Brainwave Quartet, we were translating brainwaves into musical score. And then a bunch of unbelievable people I have huge amount of respect for decided themselves, as inspired by MTF that we ran in the middle of Microsoft Research and MIT in New England, that we should actually be proclaimed as the place to go for all disciplines. And the place that unites all disciplines. And it was a huge thing for me. I had to actually then, I felt we needed to prove our worth. And this was rather a program that I wrote and that we then delivered, funded by the European Commission, where based on observing how people work together across disciplines and what they need in order to be able to support it in this environment, I ended up writing a whole program with a whole set of measures. And I was already advising to the EU at that point, so anything successful was immediately translated to policy. And this was, for instance, one of the results, that we reduced patenting from, for instance, seed idea in month 5 to product patenting already initiated in month 10. So basically, or rather, working prototype was only 4 months between seed idea and working prototype, which is actually quite incredible. And the amount of partners have not been updated. Actually, this is a very old slide. We need to update them. We've just run, of course, with Avero, and we've also run with Örebro. We've run with AI departments in different places, also with very large computer science and communications unicorns. And so we need to include those. But this is the interesting part, that industry jumped on board from the word go, and the surprising element was just how much of that was from domains of industry that we didn't expect to have in the lab, including automotive, primary industry, for instance. And just now in Aveiro, we had the vice president for AI of Tieto Every, third biggest ICT company in the world, who asked us, can I be part of your labs for a week? And here's some of the recognition. So, for instance, innovators under 35 by MIT, or European funding, or patents, or 30 under 30 by Forbes. And I was very honored, and I don't know if you can see Carlos Moedas here on the right, but I was very, very honored that Carlos Moedas awarded me with Women Innovator in 2017, which was kind of a first for this. The massive value that you get from this interdisciplinary environment and this ecosystem is that everybody brings value to the table, and the value just rises exponentially. So your return on investment is just insane. I mean, the kind of figures we get are incredible. So because of all this industry that came on board, we kept on observing a classic problem whenever we worked with AI, which was, of course, never had enough data. You can't get enough data, of course, because also it's proprietary and people will not give it to you. They only give it to you under certain conditions. Problem with interoperability. And of course, the use cases are unpredictable, so you cannot plan in advance, especially when it comes to AI. And we set to solve this. So we created something called the Industry Commons. This is why I'm now a chair of the Industry Commons Foundation, a place that would facilitate not just interoperability, but a way people share data and encourage development of tools that would allow us to do this in a very manageable way. So, for instance, our technology transfer toolkits we tested in our pilots, and that proved to be one way of solving the problem, certainly in some situations. And also we started to test already at Slush live tracking of intellectual property as it's being created, and also how to manage it so that all players, that doesn't matter if they are a young developer or if they are a postgraduate, it doesn't matter what legal teams you have to negotiate with, the rules that we have in place actually enable every single player to have fair play. And of course, some other measures which look at how do we exploit gaps between the industry verticals. This is the Industry Commons Foundation. I won't name all the people on here. They're unbelievable people. I'm hugely privileged to have them. Several of those people here had to have government permission in order to be on the steering board. But this is something I'm very proud of, or rather, there are lots of people who are proud of it because it's a huge consortium. It's like 19 official partners, but within those, there are clusters of very, very important organizations that have joined forces so they can form just one partner. And then we have 11 industry demonstrators, I believe, and then also Korea, Japan, China, Brazil on board with their contribution and American advisors. So this is a project that we have managed to pull off as the first of the industry commons projects. It's called OntoCommons, and what it's looking at is the situation that we have with industrial ontologies, the fact that some of them work really well for some domains, some of them perhaps are not so, or rather the domain doesn't have its own domain ontology. It may have knowledge graphs, it may have individual sort of methods of describing things. But when it comes to semantic interoperability, this common space is incredibly challenging. So at application level, one thing happens. At domain level, there is some consensus and some not. At middle level, we may have maybe 3 examples that work, but the top level reference is our huge challenge. We started this month, and just to very briefly summarize what happens here is, of course, we all know that the word, for instance, product in one domain means one thing, and another domain it means another. It's associated with different terms. When you construct a knowledge graph, it does a very good job for that particular domain. There's no point creating an Esperanto here at that level, because we would not be able to understand each other, and because the knowledge graph is very much anchored in the culture of that particular product or that particular industry. Domain ontologies, as I say, some work really well. We should respect that. We should incorporate them. What we are really trying to do here is an ontology ecosystem with a set of tools that will enable us to work across the different knowledge domains or different verticals. Massive challenge. So there is a marketplace that will go with this. It's not been announced yet, but it will be very soon. And of course, it's testing this interoperability. We are involved in several European marketplaces that have massive challenges that they are solving. And one is the European Open Science Cloud. We've been in charge of the strategy for the expansion of EOSC, as in the European Open Science Cloud. And that one is particularly focusing on fair data that is fair as findable, accessible, interoperable, and reusable. Not an easy challenge, but it's been worked on by a lot of very, very good people, and it's a very, very promising thing. We have, as a result of our investigation, found that industry actually really wants to use this system. So we have hope that we can actually create a system that is incredibly useful, and also started to work on the marketplace for the European Innovation Council, which is very much something that I proposed to them originally, but that's now been rolled out, which is about tracking intellectual property. As I mentioned, we have already tested that since 2017. All very, very difficult. And of course, all are what we call moonshots, because you have to kind of have real ambition to be able to solve such huge challenges. This is Imogen Heap, actually in one of our labs in Stockholm, sending her voice to the moon and back, literally, as we were going via the Dwingeloo telescope in the north of Holland. And we have MUARTS. We had our Portuguese team there as well. They were doing that. This was a voice that was converted to light waves when literally bounced off the surface of the moon. It's not actually rocket science. Actually sounds like rocket science. It's not. But what it does do, it creates this space for common understanding more than anything. Because if you do put yourself into that ratio or that parameter, into that equation, if you like, and if you hear your voice as it gets literally reflected off the moon's surface back in your ear, you do start to understand why the rest of us here need to join forces and need to start to understand each other better. So basically, here is a wonderful example of people who were participating. There were 83 people who participated in that particular instance. There was an artist called Martin Ricol Rogina who initiated this initiative. And you can see Horatio Marx, who actually spoke just before me, I believe. Horacio Tome-March, who's in the top right corner holding on the moon. So he's one of our guys who's regularly contributing to Moonshots. And just to wrap up, this is our latest. We have, as I mentioned, a lot that's coming out from the MTF labs that just ran in Aveiro in collaboration with University of Porto, with the INESC, Department of Music Interaction in particular, who ran simultaneously with us as part of their curriculum, in collaboration also with Mexico City, with the UNAM in Mexico City, Universidad Nacional Autónoma de México, also with NTNU in Norway. And with these 45 unbelievable people in the room, I will show you some of the neural net work of artificial life that is based on the Aveiro salt flats, wetland, natural, the ecosystem that it's been built on top of that. So just a preview snapshot of what sort of neural network content that's been created. We just watch this space because we're now releasing a huge amount, and there are ongoing projects that involve AI and neural nets, and very original ones. There's just huge amount of content that's been created and collaborations ongoing in these spaces for experimentation. So we always say, to wrap up, on behalf of the Music Tech Fest community, we don't predict the future, we invent it. Thank you.
Thank you, Michela, for your, let's say, overwhelming presentation. Lots of ideas, lots of concepts. It's really wonderful, and at the same time hard to process it all, because I believe there's a lot of work, a lot of to show, and unfortunately we don't have that much time. But I really thank you and congratulate you for your work, your team's work. That's really lovely. And unfortunately, we usually have a QA session, and right now, since the time is running out, I would recommend for people, if you don't mind, Michela, people that has questions, please address privately to Michela or bring to us, and we give it to you in order to answer those questions, because it's really, really interesting what you do, the way you achieve it, and mostly the way you present it. Congratulations and thank you for this presentation.
Thank you. It's been a pleasure. Thank you. And absolutely, people are welcome to get in touch with me if they have any ideas or any questions.